Here's the math notes for section 521. So they are on solving equations with fractions, also known as fractions busters. So we've been doing this quite a bit in class. So for example, if I had the equation x over 3 plus x over 5 equals 2, and I wanted to solve it for x, it would be much easier to solve if it had no fractions. Therefore, the first goal is to find an equivalent equation that has no fractions. So here's my equation over here. So to eliminate the denominators, I'm going to multiply both sides of the equation by a common denominator. So in this example, the lowest common denominator is 15, because 5 times 3 is 15. So multiplying both sides of the equation by 15 is going to eliminate the fractions. Another approach is to multiply both sides of the equation by one denominator and then the other. So you could have multiplied everything by 3 and then 5, but we can do it in one step by multiplying by 15. Either way, the result is an equivalent equation without fractions. So if we take our equation, x over 3 plus 5 equals 2. And we're going to show that we multiplied everything by 15 by putting parentheses around it, and we're going to basically distribute the 15. So in order to do this, what's going to happen is I'm going to get 15x over 3 plus 15x over 5 equals 30, because I multiplied every single piece by 15. So then I'm going to simplify. 3 goes into 15 5 times. I get 5x plus 3x, because 15 divided by 5 is 3, equals 30. And then I'm going to get 8x equals 30. And then when I divide by 8, I'm going to get x equals, and I can leave it as a fraction, but simplified, 2 goes into each, so I get 15 over 4. So that's my final answer. So the number that we use to eliminate the denominators is sometimes called a fraction buster, because it's basically busts apart the fractions. We get a nice equation that looks just like this, where it's got no fractions, no decimals in it. And then once you found the solution, always remember to plug it back in, check your answer to the original equation.